Hello, welcome to lesson 1 on the topic number system. Before I begin this lesson, let me tell you the importance of this topic called number system. Number system is important in aptitude not only because you will have direct questions from this topic called as number system in various exams, but also because the entire domain of aptitude is all about numbers. So be it percentage, be it a topic like profit loss, or maybe time, speed, distance and time and work, permutation, combination, everything will deal with numbers, and that is where numbers become a very important part of our learning. In this class, we are going to have a look at what are the different types of numbers, how are numbers classified. Therefore, primarily we are going to talk about the number system tree. Alright, I hope you enjoy the lesson. I would like to begin by asking you a question. Do you know where numbers actually originate? Or, for that matter, if I were to ask you, can you tell me one category under which all numbers in this world fall into? Think about this. I'll begin my lesson from this point. All numbers in this world are actually complex numbers, and therefore complex numbers is where the number system tree actually originates. The obvious question is, what is a complex number? Any number which can be written in the form of a plus ib. I'm sure all of you have been introduced to this earlier. Any number which can be written in the form of a plus ib, where there is a real part a and an imaginary part ib, is what is called as a complex number. And every number in this world is actually complex in nature. Complex numbers further get divided into two branches. The first part of the tree, the first branch, is when b is equal to 0, we call them as real numbers. And the second part is where a is equal to 0, we call them as imaginary numbers. Let me share here with you that for many students, there is no difference between complex numbers and imaginary. They would say that, sir, imaginary numbers are the same as complex numbers. No, I'm sorry, it is not. Imaginary numbers, as you can see, is a subset of complex numbers. So what are imaginary numbers? Mathematically, when the a part of a plus ib becomes 0, that set is called as imaginary numbers. And when the b part becomes 0, then the category is called as real numbers. Okay, this is the mathematical way to explain. Is there a basic common sense to understand this? Absolutely. And what is that? Real numbers are all those numbers which can be shown or represented on a number line. Hence the name real. Okay, whenever we have certain names or connotations, right, then they have a particular meaning. So real numbers are called as real because they can be shown or represented on a two-dimensional number line. What about imaginary numbers? I'm sure we are aware that imaginary numbers need a three-dimensional plane, which is called as an Argand plane or a Gaussian plane or an imaginary plane to be represented, right? Hence the basic difference between real numbers and imaginary numbers. Now, when we talk about aptitude, more often than not, aptitude will not get into the domain of imaginary numbers. You know, we have all taken engineering entrance exams earlier in our life. They do deal with imaginary numbers, but as far as aptitude testing is concerned, it is primarily going to talk about real numbers. Okay, so we are going to focus on this part of the tree, right? Now, real numbers further get divided into two parts. The first part is rational numbers, and numbers that are not rational are called as irrational numbers. So complex numbers getting divided into real and imaginary, real numbers further getting divided into rational and irrational numbers. Let's first talk about irrational numbers. And let me start with this interesting example. The first example that most teachers present to students for an irrational number is pi. So immediately a question comes to my mind that, sir, pi is 22 by 7. Alright, pi is 22 by 7. By the way, before that, let me tell you what exactly is a rational number. Any number which can be written in the form of p by q, where p and q are both integers and q is not equal to 0. They are rational numbers. Okay, so I will repeat this definition. Any number which can be written in the form of p by q, where p and q belong to integers, we will represent it by capital I, and q is not equal to 0, is a rational number. That means what we are trying to say is, we are saying there are certain numbers which can never be brought into the form of p by q. They are irrational numbers. Okay. So let me come back to my example. So what is the first example of an irrational number? It is pi. So what is the immediate question that comes to a student's mind? Sir, pi is 22 by 7 and 22 by 7 is p by q. And you are giving pi as the first example of an irrational number. So there is a mismatch. What is the truth? The truth is 22 by 7 is an approximate value of pi that we take for calculation purpose. Right? If you actually Google this, and we all have the resources today, if you Google this, the actual value of pi is 3.1415 and so on. And you know what? There are people who have calculated the value of pi up to 22 places of decimal, and it is still going on. It happens to be the research work of many people. Okay? Therefore, what I am actually trying to tell you is, pi is a non-terminating, it is a non-terminating, non-repeating decimal. And therefore, when I say that today it has been done up to 22 places, it is going to continue, because this will never end, because pi is an irrational number. Alright? So let's complete that discussion. So what is pi? It's an irrational number. What is 22 by 7? It's a rational number. But sir, isn't pi equal to 22 by 7? No. Pi is approximately equal to 22 by 7. Its actual value is not 22 by 7. Alright? What are the other examples of irrational numbers? Root 2, root 3, root 5, cube root of 4, cube root of 4, root 7, root 8, and so on. You keep writing. Okay. I don't know whether you are aware of this or not, but this is beautiful. What are we talking about? Take any number which is not a perfect square and express that number as its square root. It will definitely be an irrational number. So, root 2, root 3, root 5, root 7, root 8, they are not perfect squares. Right? I hope you are understanding. I did not write square root of 4. I wrote cube root of 4, because 4 is not a perfect cube. So take any number which is not a square, take any number which is not a cube, take any number which does not have an integral value of 4th power and express it as its nth root. It will absolutely be an irrational number. I don't know how many of you know this or remember this. This category of numbers are popularly known as surds. So all surds are examples of irrational numbers. Alright, a number which can never be expressed in the form of p by q. And what is the property? It's a non-terminating, non-repeating decimal. Now let's come to this side. What is the property of a rational number? A rational number is a terminating decimal. What do you mean by a terminating decimal? It will end. Can you give an example? Absolutely. 6 by 5, 1.2, or 5 by 4, 1.25, and so on and so forth. So a rational number is a terminating decimal, or if it is non-terminating, then it is definitely repeating in nature. If it does not terminate, it will definitely repeat itself. Can we have an example? Why not? 4 by 3, 1.33. Or for that matter, let me take 20 by 11. 20 by 11 is what? 1.11888, right? Then I'll have 2, so 11, 1, 11, 88, 1, 88, 1, and so on. So 1.818181 and so on. So rational numbers are either terminating decimals, or if they are non-terminating, then they are definitely repeating in nature. We also use the word recurring, right? Now, I would not say that aptitude testing does not get into irrational numbers. I'll not say that, because when you talk about algebra, when you talk about quadratic equations, when you talk about maxima minima, you will have values that are irrational. But mostly the topics of aptitude which belong to arithmetic, mostly they will be using rational values. Alright. I'm sure you would not have very frequently come across a question which says that the speed of a car was 50 root 2. It is not needed. I don't need a value called 50 root 2 to test the skills of a student. 50 kilometers per hour, or maybe 72 or 60, an integral value is good enough, right? So I'm not saying irrational numbers are not used, but I would still say they are not used so frequently in aptitude testing. Alright. The tree does not extend from here. It stops here. This branch stops here. Okay. This branch extends. Rational numbers further get divided into two parts. I hope you are able to see the board. Integers and fractions. Okay. Integers and fractions. Integers further get divided into three parts: negative integers, 0, and positive integers. Negative integers, 0, and positive integers. Alright. So there is a very important learning here. And what is that important learning? 0 by definition is neither a negative integer nor a positive integer. Very important. 0 by definition, 0 as a number, 0 as an integer, is neither a negative integer nor a positive integer. You might be asking yourself this question: does it actually make a difference whether 0 is neither a negative integer nor a positive integer? Absolutely. Suppose you have an equation and you have been asked to calculate the positive integral solution. We do this a lot in algebra, in permutation combination, we use this a lot. You have been asked to calculate the positive integral solution. Now, positive integers will not include 0. So, positive integral solution means it will start from 1, 2, 3, 4, 5 and so on. But the same question, if it asks you to calculate the non-negative integral solution, I hope you are paying attention. If it says, if the word gets changed to non-negative integral solution, so what is a non-negative integer? A non-negative integer is anything that is not negative. Okay, so is 0 negative? No, 0 is not negative. So a non-negative integral solution will start from 0 and will go to 0, 1, 2, 3, 4, 5 and so on up to infinity. Alright. So starting from complex numbers, which is the origin of all numbers, and coming down to negative integers, 0 and positive integers, what we have on the board in front of all of you is popularly known as the number system tree. Okay. Now, you think about any number in this world, any category, it will fit into any particular part of the tree because there are no other numbers, types of numbers beyond this tree. Okay. Now, before I close, what are non-negative integers popularly known as? 0 and all positive integers. 0 and all positive integers, what are they popularly known as? They are also popularly known as whole numbers. 0, 1, 2, 3, 4 and so on. Right? And only positive integers, what are they called as? They are called as natural numbers. Alright. So starting from complex numbers and coming down to whole numbers and natural numbers towards the end, this is what is called as the number system tree, and this happens to be our basic introduction to the topic of numbers. Thank you.